Hello guys and welcome back. Let's see how we can troubleshoot a direct driving of a motor. So let's say you have your overload here, your contactor here, and this is your control circuit, and this is your inner contactor and how it looks like. What kind of problems you might encounter with this direct motor driving schematic? Let's say you press the start button and well, the motor is on, but when you release the start button, the motor is turning off. The problem is that you did not connect the NO of the contactor with your start button in this way. Because these push buttons, when you press it, it latches. As you can see, when you press it, you're conducting power to the contactor coil here, but when you release it, what you're doing is you're disconnecting the power. So what you should do here is make sure that this K and O is connected in parallel with your push button. Now this NO, let's say this is your coil, these are the 2 pins for the coil. Now the NO is usually here and it needs to be connected in parallel with your start button. Now another problem is, let's say a customer called you and said, okay, the motor is always latching and it's not turning off. And I'm pressing the stop button right here, which should disconnect this contactor, but nothing is happening. Well, usually this happens when your motor draws too much current, your overload is problematic, and it allowed that overcurrent. And what happens is your contactor contacts here gets melted, so these get shorted together, right? It becomes independent of the coil because, okay, the coil here is trying to pull these to close the circuit, but these are already melted and closed already. So what's going to happen is the motor will be conducting power all the time. The way to fix this is you need to replace this contactor because it's already fried. Now, let's say that the customer says, okay, my overload is tripping on its own after a few seconds. There is a few scenarios for the reason of this tripping. Maybe the installer did not adjust the current limit for this overload. You know, maybe the motor is drawing, let's say, 3 amperes, but the technician has set it to 2.5 amperes. Then, well, this is below the threshold and will cause this overload to trip. So what you need to do is go check the motor, check what current it will draw, and then adjust here accordingly. Now, if you go there and check, okay, well, the current adjustment is correct. That's not the problem. There is some other causes. Maybe your motor internal connection is problematic, so you need to go and check the connection in the motor. Since this is direct driving, so there will be only motors up to 3.3 kilowatts. So you need to make sure that it is delta connected in the motor side. Now, if it is delta connected and it's still tripping, well, there is another reason. Maybe the load the motor is driving is too large, so it is mechanically too big for the motor. This will cause the shaft to try to rotate, but, well, it's too heavy. It will draw too much current and will cause this overload to trip to prevent the motor from being burned out. Now, another thing, maybe the gears of this mechanical thing get stuck. So maybe the load is not too big, but the product it's trying to process got stuck. Let's say you have a mixer and the product gets stuck in the blades of this mixer. And, well, so this will prevent the mechanical parts from rotating, will cause the motor to draw too much current, and the overload will trip. So you need to follow these 4 schemes here and check what is the problem. Now, if none of them works, well, if none of them works, maybe the motor has some problem from within and you should take the motor itself to the maintenance. I mean, if you try all of these, nothing works, then it's not an electrical problem anymore. It's not your business anymore. As an automation designer, you need to take this motor to someone who can fix your motor. Next, let's say that you have connected a motor and it's rotating in the opposite direction. This happens 80% of the time. We just connect a motor, we press the start, and, well, it just rotates in the opposite direction. What you need to do is just connect any of these in the opposite direction. So, you know, you're getting 3 cables from the motor connected to your electrical panels through some terminal blocks. At these terminal blocks, just replace any 2 phases. Like, take this face connected here, take this face connected here, and the motor will rotate in the opposite direction. This is the solution for that. Now, another problem that you might encounter that your motor is running too slow. This happens sometimes, and assuming that you're not using any VFD, maybe the motor is connected in star. The star connection is used to limit the inrush current. The star connection is used to limit the inrush current in the motors that are 5.5 kilowatts and above. So you need to make sure that it is connected in the delta so that it can operate at its full potential. This happens sometimes, especially in the motors that you're assembling yourself. So you need to make sure that you assemble it in delta so that you can get your full power and full speed. So this is it for this lecture, guys, and see you in the next tutorial.